Well, howdy there, Internet students. This is Mr. Hermanson again. So we're going to do lesson 10.2b. We're going to solve and graph inequalities. Sometimes inequalities need to be simplified before graphing the solution set, the set of all numbers that make the inequality true. Here are some examples of inequalities that need to be simplified before finding their solution set. So you guys, I just want to remind you of a couple things here. That this would be any number less than 2. So on a number line you would see open circle at 2 because that's not included. And then the solutions are everything to the left side of that. Okay, so the arrow would be going this way. If it was less than or equal to 2, it would be the same as the last one, except you would fill in this. Okay, and then greater than 2 would be numbers bigger than 2, so they would start at 2 and go that way. And then and it would be an open circle. So like that. And then greater than or equal to would be a closed circle. Like that. All right. So so what you're going to do is, in order to solve an inequality, it's the same as solving an equation. It's just that there's going to be a whole bunch of answers, and when you solve it, you're just finding the starting point of those answers. I call it the boundary point of those answers. So if you have x plus 8 is less than 14, you can think of that you're looking for numbers that you add 8 to. Okay, so you can use your backtracking diagram to get 14. So in order to figure out what those numbers are, you would start with 14 and subtract 8, and that would give you 6. Okay, and so I just went over what that is. All right, so in this one, I'll do this one with you. So since we are subtracting 5 to get numbers that are greater than or equal to 9, backtracking, we would add 5, and we would find that any number greater than or equal to 14 would make this true. So we would put because there's an equal, we would put a closed dot on 14, and then we would shade to the right because it's greater than or equal to. Okay? So when you're graphing, x equals 3 is just a dot on 3. X is greater than 3 would have an open circle on 3 because it's not including that. And x is greater than or equal to 3 would have a closed dot. All right, so to solve this, backtracking, you would just do 12. Since this is 3 times x, you would just do 12 divided by 3, which is 4. Since it's less than, so your solution would be x is less than 4, you would put an open circle on 4 and shade this way. Okay, now this is divide by 3, so when you're backtracking, you would do times 3. 6 times 3 is 18. So x is any number greater than or equal to 18. That would be a closed dot on 18 and any of these numbers this way. Okay? And also remember that you can switch it around. That just switches the inequality around. Okay? So x plus 5 is greater than 11 is the same as 11 is less than x plus 5. All right, now something weird happens when you are backtracking. Every once in a while, something weird happens, and by going through this, we're going to figure it out. So what you're going to do is, in this table, and I'm going to let you do this, but it says add 2 to the numbers in the original equality, so like we're balancing, and then we're just going to decide if it's still true or false. So If we add 2 to this side, we get 4. If we add 2 to the 6, we get 8. And then we know 4 is less than 8. So by using that same sign, this is going to be true. All right? So go ahead and do the rest of these and then just answer true or false. Most of them are going to be true. If you subtract, if you add -2 to both sides, 2 plus -2, you get 0. And if you do 6 plus -2, you get 4, and 0 is still less than 4. So that would be a true one. All right, go ahead and do the rest of them. All right, so if you did that correctly, you found that it was always true except when you did this, multiply by -2 or divide by -2, because -4 is not less than -12. -4 is greater than -12, actually. Same on this last one when you divide it by negative. So circle those and just kind of remember that you can't just keep the sign the same on those. So the inequality will stay the same when you add the same positive number to both sides. So the inequality will be the same in order to be true. As you add negative number to both sides, they will be the same inequality. If you subtract the same positive number, they will be the same. And I'm just going down the list. The only time they won't be the same is when you multiply both sides by a negative number. The inequality actually is reversed to make it true. And when you divide both sides by a negative number, you have to reverse it. All right. So I'm going to show you a couple examples where you have to where you're going to have to reverse the sign. So we want to do 20 divided by -4, right? Okay, which is -5. So x. So let's put -5 on here. So 0's here. And if I use the same sign, greater than or equal to, that means I'm talking about these numbers this way. Don't write this down yet. I just want to show you that. So number like 0, if I put 0 in there, I actually get -4 times 0 is 0. 0 is greater than 20 does not make sense. So what makes sense is numbers less than or equal to -5. So the actual answer looks like this. Okay, to solve this one, you are going to, so we're backtracking. We're starting with less than -7, or sorry about that. Our result is less than -7. To get there, we're multiplying by -2/3. And then we're going to subtract 1 and to end up with numbers less than 7. So I'm going to add 1, which gives me 8. And then remember when you're multiplying by a fraction, dividing by a fraction undoes that, but the way you divide is you multiply by the reciprocal, which would be -3/2. And that would give me -12 for a result. Okay, now less than -12 doesn't make sense because numbers less than -12 will not be true. We have to switch the sign because we multiplied by a negative right there. So greater than 12. And I would make my graph like that. All right. You can also have equations, inequalities like equations where you have the variable on both sides. Now when you have that, you have to do the balance to get it so you only have the equation on one side. So I might subtract y away from both sides, take away the y. Then I would get negative 3 is greater than 1y plus 5. Now I can just backtrack by doing negative 3 minus 5, which is negative 8. So I have negative 8 is greater than y. And that's the same as y is less than negative 8. So to graph that, I would do that. All right. I think I'm going to let you try the next 3, see what you get. Now, the only time you will have to worry about the sign being different is when you, so let's write this here, reverse the sign if you multiply or divide by negative in the process of solving. So multiply or divide by negatives. All right, so go ahead and try 9, 10, 11. All right, did you remember to switch the sign? Like on this one, you had to divide by negative 2, so that would reverse the sign. Okay. So remember that expanding an expression like this, you would multiply 2 times 2 and also 2 times 12. So without parentheses, it would look like this. So on this problem here, you would do 14x plus 4, and you would get rid of the parentheses, 4x minus 24 first. Then you would do your balancing, maybe get rid of the 4x here. And now you can backtrack. Remember that this is negative 24 when you have a minus like that. And so you're backtracking here. I'm going to be dividing by a positive number, so I don't have to worry about the sign changing. So I'm going to do negative 24 minus 4 is negative 28. Divided by 10 is negative 2.8. It's equal. So the graph looks like that. All right, so go ahead and summarize what you learned here and try the homework problems. Message me if you have any concerns. Other than that, we'll talk to you soon.